AP Calculus, ABC Exam Review, Differential Calculus Fundamentals. This is question 3 of the series, and we're going to be comparing features of functions, specifically minimums, periodicity, odd and evenness of functions, and y-intercepts. F is a function defined on all integers between -3 and 3. So -3 and 3 inclusive. So in case you forgot what integer means, they just mean whole numbers, like these represented in the table. Okay. And that includes 0. And an inclusive range of numbers are a set of numbers that span the x-axis, and whatever the question is of interest, the values include the first and the last value. Because sometimes when you're dealing with a range of numbers, they just include the numbers in between and not necessarily the first and the last value, okay? So the first and the last value are included. All right, so the values of f are given in this table below. Now g is a function defined on all real numbers, okay, between -7 and 7 inclusive. So in case you're wondering what real numbers includes, that's like the numbers we normally use, like 1, 15.8, -0.3, and a fraction like 1/2. So basically, all numbers that are positive, negative, large or small, like you can have decimals or fractions and whole numbers. Real numbers are all numbers that are not imaginary, and when I say imaginary, I'm referring to the term I, which is assigned a value of radical -1. So anything that includes this is not real, okay? And the graph of g, the function g, is given below in terms of x, okay? The question of interest is which of the features that are named below are shared by both f of x and g of x. And so select all that apply. So they have the same minimum. They are both periodic, meaning they have like a pattern like repetitiveness. They're both even, and they have the same y-intercept. So let's see. The best way to approach this type of problem is to examine each option one at a time. So there's no special magic trick. You just work through each option strategically, one by one, not wasting any time. So let's check the first option. We're going to examine the minimums. And the minimums deal with the f of x, or you could say y values, okay? So the minimum for x is going to be -4. I said x, I meant f of x. And the minimum amongst the g of x values, let's see. Well, since this looks like a symmetric thing, it's going to be approximately around here. As well as here. And this value is a little less than 7 at about 7.25. So we can eliminate the first option because they don't have the same minimum, okay? Yeah, 7.25 and 4 definitely don't correspond. All right, on to the next one. Let's consider whether or not functions f of x and g of x are periodic. So in case you're unfamiliar with the term periodic, a periodic function is a function that repeats its values over regular intervals. And like, for example, you'll have a lot of trig functions that repeat values over the course of 2 pi. That's also 360 degrees. All right, so pi, two pi. So over this period, it'll repeat again. So here you see it going up, down. Now, if you look at the table for f of x, over this particular range from -3 to 3, this is forming a parabola, okay? Something that looks like this, with the vertex being at 0. So although we see similar values because it is a symmetric function, it's not periodic. Those values will duplicate to the right and the left of 0, but that's it. You'll never get a repeating cycle. And the same here, function g of x is an inverted parabola. So you'll get the same output or y values to the left and right of the midpoint, which is centered around 0 as well, but they'll never actually repeat. So try to just get that straight in your mind because it can be a little confusing. Parabolic functions are not repetitive, okay? Therefore, they're not periodic. Now, the last option that we need to examine is whether or not these functions are even. And so it's important to note that a function f of x, or let's say g of x, is even if the graph of the function is symmetric with respect to the y-axis. Okay, so clearly g of x is symmetric with respect to the y-axis. And also, if g of negative x is equivalent to g of x, the function is even algebraically. So algebraically, a function is even if and only if g of x is equal to negative g of x, or f of x is equal to negative f of x for all x in the domain of f, okay? And a function is odd if the graph of the function is symmetric with respect only to the origin. All right. Now let's check the y-intercepts. So you get the y-intercept by plugging 0 into either function. So 0 is going to be the x value that we're plugging in. And we see that when we plug 0 into f of x, so f of 0, the function in terms of 0 for the function f is going to yield an f of x value of -4. And likewise, when we plug 0 into the function g of x, g of 0 gives us a value of, let's see, this looks like 5. So we can eliminate this last option. The functions don't have the same y-intercept. So the correct answer is that both functions are even because f of x is equal to f of negative x, not negative f of x, and g of x, which is a parabola that's symmetric about the y-axis, is equivalent to g of negative x. So if a function is symmetric about the y-axis, that also implies that it's even, okay? But in order for a function to be even, it doesn't necessarily have to be symmetric about the y-axis. It could be symmetric about some other line. All right? Okay. So both functions are even because f of negative x equals x amongst the domain of f of x, and g of negative x equals g of x for the domain of the function g of x. Okay?